All right, back on workbook page 83. So this is the bottom half of the page on 83. And it's asking me to continue estimating non-perfect squares and plotting them on a number line. So the first one I have, it may be a little hard to tell, but this is just a square root of 32. It's positive. Well, the square root of 32 falls in between two perfect square root problems. It falls in between the square root of 25 and the square root of 36. Now, I know there were no blanks here. You have to take the initiative yourself and start to use the information and knowledge you've already learned from previous classes. So, the square root of 25 is 5, and the square root of 36 is 6. But which one is it closer to? I know that it's going to fall in between these two whole numbers. It's going to be in between 5 and 6, but I need to know, where is it at between 5 and 6? So I go back to this original problem. The square root of 32 is how many digits from 25? Well, that's 7 digits away between 25 and 32. And from 32 to 36 is 4 digits. So 4 digits is much closer. So I know that the square root of 32 is closer to 6 than it is to 5. So on my number line, I'm going to plot my answer closer to 6 than I did to 5. All right, the next problem is actually a negative square root. It's the negative square root of 20. Well, it works pretty much the same way, except if I'm trying to keep these in order from least to greatest, it kind of seems a little bit backwards, almost flip-flopped. So what are the two perfect square root problems that are surrounding 20? Well, one of them is 25, and the other one is 16. Normally 16 would come first and then 25 would come second, but since these are negative, negative 25 is actually a smaller number than negative 16. So negative 25 comes first, negative 16 comes second. The negative square root of 25 is negative 5, and the negative square root of 16 is negative 4. So we know that it's in between negative 5 and negative 4. Now this seems backwards, but because they're negatives, this is the correct way for a number line. As you can see, negative 5 is to the left of negative 4, so that's the correct order. It matches the order. If you were to get these reversed, you would still get the same final answer. You would still get it right, and you would still get credit for it. So I know my final answer is going to fall in between these two numbers, but where at? How close to negative 5 or to negative 4? Well, negative 25 is 5 digits away from 20, and 20 is 4 digits away from 16. So I'm almost dead even, but just slightly, just barely closer to negative 4. It's 1 digit closer to negative 4 than it is to negative 5. So I'm going to the center in between them, and then I'm going to go over to negative 4 just a little bit. So it's just slightly closer to negative 4. And if I was to estimate this value right here, I would say that the negative square root of 20 is about negative 4.4. That would be my estimate. All right, the last one down here that I'm going to work out, the square root of 48. The square root of 48 falls in between two perfect square roots, and it would be the square root of 36 and then the square root of 49. The square root of 36 is 6, and the square root of 49 is 7. So I know it's going to be between the numbers 6 and 7. But which one is closer? Well, from 36 to 48, that is 12 digits. From 48 to 49, that's a single digit. That means that the square root of 48 is going to be extremely close to the square root of 49, which we know is 7. So while we are extremely close, just 1 digit away from 7, we did not actually reach 7. So our dot, our final estimation, cannot actually touch 7, but it does need to be very close to 7. And you could estimate that amount at probably around 6.9, 6.93, 6.95. It's going to be very close to 7, but not quite 7.